Alrighty. Here we go. Turn to the next chapter with some logical terminology. So as I said, a lot of definitions today, a lot of new terms that you've never heard before, but this will be good for you. It builds character. Okay. We're going to start with some simple pattern recognition. So for instance, what are the next two numbers in the sequence? This, by the way, is called a sequence. Let's talk about how it works. This is a numerical sequence. I've given you 7 numbers to start. Your goal is to find the next 2 numbers in the sequence. And you'll notice the little dot, dot, dot at the end, meaning this continues on after those next 2 numbers. Okay. What are those next 2 numbers? Go, Kurt.
2134.
Say again?
2135.
Why?
Because it's the Fibonacci sequence where you add the 2 numbers that were previous to it.
Nicely done. What she just gave me is what's called the rule. Why are those the next 2 numbers? You've all heard of the Fibonacci sequence, right? Add up those 2 numbers. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, etc., etc., etc. All right, let's try another one. What are the next 2 letters in this sequence? Duh.
N then T.
N, then T. Why?
Because, like the O represents 1, the first letter, then 2, 3, 4, 5.
Beautiful. First letters of the numbers in numerical order. What are the next 2 decimals? Nothing? What's significant about the decimal 0.5? It's 1/2. What's significant about the decimal 0.667? 2/3. And 0.75? 0.8? So the next 2 decimals would be? Right, which would be 0.833 and 0.857, which are fractions. 0 over 1, 1 over 2, 2 over 3, 3 over 4, 4 over 5, 5 over 6, etc., etc. Next 2 letters. This one's a little nasty. Steven, guesses?
No.
Gesundheit. John?
Maybe the letters align with each number. 1 through 25.
Are you saying like A is 1, E is 5?
That's just a guess.
It's not a bad guess. What do you got?
N.
N as in narwhal and P as in puma? Why? Before I click, what's your rule? You just felt it about it?
Those are order, EF and HI and ALM.
Okay. So you just thought that we would follow that sequence. The answers are actually N and T. Rule here, they're the letters without curves. So there's not always a mathematical answer for the problems. Sometimes it's something goofy. Next 2 in this one. Okay.
16, 18,
Why?
because it's, the pattern is, they go up by 1 twice and then 2 twice.
They go up by 1.
Or they go by 2 twice and 1 twice.
They go up by, okay, so 4 to 6 is 2, 6 to 8 is 2, 8 to 9 is 1, 9 to 10 is 1, 10 to 12 is 2, 12 to 14, okay. Dean, you got something different?
16 and 18,
Because?
they're skipping prime numbers.
Skipping prime numbers. Is there another way? No. Okay, yeah. Skipping prime numbers would be listing other non-prime numbers. What are the non-prime numbers called? No?
Composite?
Composite, very nice. Those are the composite numbers. Strangely enough, KK, that is a viable pattern from what we had demonstrated there. This one you're definitely not going to like. And the answers are not 200 and 500. In fact, I'll tell you the answers, because you would never get this. Can you tell me the rule? What's significant about those numbers? Steven,
I feel like, oh, wait, never mind.
I'll give you a hint. It's not mathematical. Go ahead.
I don't know why, but like, if you multiply 1 times 100 to 100, 2 times 50, 5 times 20, and then 10 times 10, does that have anything to do with it?
No, because it's not mathematical.
Oh, okay.
What?
Probably because there's like the zeros, like each time goes up by like tens or hundreds, so like 1 through 5 doesn't have any zeros on, 10 through 20 is 1 0, and then,
And if that were the case, then it would be 100, 200, 500.
oh yeah.
Yeah. What do you got?
There's like a $1 bill, $2 bill.
Very nice. Denominations of U.S. money. $1 bill, $2 bill, $5 bill, 10, 20, and there are or were at some point $500 and $1,000 bills. This one's different. Okay. Notice I don't have the 3 dots after it. This is what's called a finite sequence, meaning it ends. The question is, why are those numbers in that particular order? Go ahead.
Numbers 1 through 10 in alphabetical order.
Ooh, very nice. 8, E-I-G-H-T is the first number spelled out alphabetically. Good. Okay, so these are pattern recognitions for sequences, whether they're infinite or finite. We can also do, we'll get to it in a second, but what we're dealing with is what's called a conjecture. Okay, so what we're doing is, a conjecture is defined, like it says up there, as an educated guess. Okay. So if I was to ask you, Al, how old am I? 42. You'll go far in life, Al. Is that a conjecture? Why is that an educated guess, Al?
Because you gotta be older than us, because you're a teacher.
Theoretically, yes. I could be 16.
If you're going on that logic, you should have to be older than.
No, but you have to
You have to go to college.
Yeah.
You don't have to.
To be a teacher.
Yes, you do.
I mean, who knows? It's way too early for this.
Yeah.
Wow, buzzkill over here.
I'm tired.
So you're basing your answer purely on the fact that I have to be older than you.
Yeah.
And go to school, and have teaching experience.
How about the fact that I'm standing here? And you can look at me and guess that I'm about
Yeah.
X number of years old. That's an educated guess, right? Al,
Yeah.
how old's Bill Weinstein? You know Bill from over by there. How old's Bill?
I have no clue.
What do you think?
3.
3. Conjecture?
No.
No, that's just a random guess. You have no idea who Bill is. Right, Bill could be a cat, he could be a 140-year-old guy working at the VFW hall, could be a barista at Starbucks? You have no idea. Okay, so. Last term. We're going to do a ton of work with inductive reasoning. There's two different types of reasoning, inductive and deductive. We're doing inductive reasoning. Inductive reasoning means we take a bunch of examples and then we make a general statement. So I take my little clicker and I drop it. Take my clicker, I drop it. I do that 10 times. Eventually we're going to realize that anytime I drop the clicker, it's going to fall. The same thing is true here. We'll look at a triangle and talk about the angle sums in that triangle. Then we'll look at a different triangle. And then eventually we'll be able to make general statements. And we've already kind of done that. As opposed to deductive reasoning, which goes the other way. It takes general statements and looks at specifics. Okay, so Billy's back. And he's preparing toast for breakfast. After a few minutes, the bread popped up, but was not toasted. What conjectures can you make as to why the bread is not toasted? Go ahead.
It wasn't there for long enough.
Wasn't in the toaster long enough. Popped up too early. Very good.
The heating was too low.
Say again?
The heating was too low.
Set too low for a light setting.
Toaster wasn't plugged in.
Toaster wasn't plugged in. However, my toaster won't click down if it's not plugged in, strangely enough. Maybe I have a fancy
How would it
toaster.
pop up though if it wasn't plugged in?
What's that?
How would it pop up though if it wasn't plugged in?
That's a good question. I don't know. Mine won't go down, so it won't pop up either. You know what I'm saying?
Yeah.
What else?
The toaster's broken.
Toaster's broken. Anything else? Go ahead.
He put in some frozen bread.
Ooh.
Uh,
So if you put in frozen bread, the toaster would be at the correct setting, the toaster would be working, but it would be frozen to the point that it wouldn't come out of the toaster toasted, it would just be thawed. I'm going to do this an infinite number of times.
What?
Okay, now we're. All right, good. So you understand why this is a conjecture, because you have a bunch of information. You have a toaster sitting in front of you. You have this bread that doesn't get toasted. By the way, what does the word, or what do the letters P-O-S-T spell? Post. And what do the letters M-O-S-T spell? Most. And what do you put into a toaster?
Bread.
oh!
my god!
Suckers! You put in bread, it comes out as toast.
That's like the thing when where it was like, okay, spell, so say,
Pork.
oh no, wait, no, say sport.
Spork?
Yeah.
Sport.
Spells right.
S-P-O-R-K.
Say it 3 times.
Sport, sport, sport.
Say it 5 times.
Sport, 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 sport.
Say it 8 times.
Oh yeah.
Sport, 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 sport.
Spell it again.
S-P-O-R-K.
What do you see your
A spoon.
Oh, I got
Say
one.
4.
The program.
Yeah.
Alright, spell silk.
Silk? S-I-L-K.
Say silk 6 times.
Silk, 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 silk.
5 more times.
Silk, 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 silk.
What do cows drink?
What do cows drink?
Yeah.
Water.
Oh, I was about to say
Because
milk.
now I know where you're going with it, but that would
I
be.
was about to say milk.
Cows don't drink milk, that would be cannibalism.
Wait, something bad.
Isn't it? No, that would be if they ate hamburgers.
Yeah.
Okay. Hey, what's the next picture in the sequence? Draw it in your notes, please.
Oh yeah, what do baby cows do? They drink water too.
They drink milk. That's why cows produce milk.
Yeah. Just we drink milk doesn't mean we produce it, right? It's like if we eat popcorn, we don't make popcorn.
That would be pretty cool, though.
It's pretty nasty. Like you know where it's been made out of. Yeah.
All right. appears everybody's got this. 4 across the bottom, 4 up, similar shape. Did anybody consider the following question? What color would it be?
Green.
Why? Eric, you okay?
Yeah.
Okay. Why would it be green? Colors of the rainbow. Roy G. Bibb. Very good. Okay, so we're going to start making some statements. And those statements might be true or false. And in fact, we're going to spend a lot of time today talking about whether or not a statement is true or false. If the statement is false, then you should be able to give a reason why it's false. And that reason is what's called a counterexample. So if you were to say something like, all chairs are brown, that would be a false statement. My counterexample would be the 30 chairs in this room that are all blue. So it's a statement that proves something false. In order to prove a statement false, you only need one counterexample. And this is where the logic becomes very weird. If I want to prove something true, I have to show it true for all possible examples. So if I made the statement, all chairs are brown, I would have to find every chair in the universe and confirm that it's brown. However, proving something false, I just need one counterexample. So let's look at these two statements. We'll do the mathematical one first. All real numbers, x. That x squared is always greater than x. Is that a true or false statement? False. How do you know it's false?
Because there's, X could be.
Well, you're overthinking it. How do you know that statement's false? No. Both of the following statements are false. I told you it's false. What makes it false, though, other than the fact that I told you? What's the counterexample for that? 1. Is 1 squared greater than 1?
No.
No. Other counterexamples? 0. 0 squared greater than 0? No. Other counterexamples? And we could have stopped at 1 because we only need 1. How about a half? What's 1/2 squared? 1/4. Is 1/2 greater than 1/4? Sorry, is 1/4 greater than 1/2? I said it backwards. Okay, how about statement number 2? All mammals bear live young. You're in biology now, aren't you? Is that a true or false statement? False. Counterexample. The platypus. Well, because that's about the only counterexample. What's that?
The echidna.
Ooh. Isn't that a SUV by Chevy?
Put your pants eater.
Where'd you get the new echidna? I don't know. It's pretty cool, right? It's a what?
Echidna.
I know, but what is it?
It's like a pants eater.
Can I look it up?
Sure.
Wait, so what do platypus do?
Whatever they want, they're platypuses.
Yeah.
By the way, did you know, fast fact, I know you all, are you of the generation with Perry the Platypus?
Yeah.
Okay, good. Fast fact, do you know the bite of the platypus is poisonous?
Yeah.
Yeah.
What was that shiver thing you did?
Okay, so I have a quick video to show you, and there's a reason I'm showing you this video. Number 1, because
It looks like a little
No wonder they can't.
the reason I'm showing you this video is 2 reasons. Number 1, it's a fun video to watch, and number 2, we want to talk about the logic behind this video. I'll show it to you first, and then we'll go from there.
You probably get robbed.
So the question is, whose fault is it that she fell down the hole? Shall we watch it again?
Yeah, all of the above.
All of
I think didn't she notice? She noticed that she was like,
There are 4 people in this scenario. There's the woman that opens the hatch. There's that guy that walked past the hatch, and then is just standing there, and then there's the guy that entered from the left that's right here.
Everybody else except the lady that fell.
Whose fault is it?
Everybody else except the lady who fell.
What's that?
Everybody else except the lady who fell.
No,
Lady
all
who
of
fell
them.
stuck back in the
Everybody
boat.
except the guy who walked in.
No, all of them.
Everyone who was present
Everyone except the lady.
at the time.
They're all at fault?
Yes.
No,
Didn't warn her.
It's not the lady's fault.
The guy.
Lady should have been watching where she was going.
Yeah.
The guy should
It's
have
not
told
that
her
guy's
to walk
fault. That's
around.
not
It's
The guy that walked past should have said, hey, there's a gaping hole in the floor, don't fall down it.
The lady who went down should have closed the thing.
The lady that went down should have, or at least said, hey, everybody, I'm creating a giant hole in the floor, don't fall down it.
And then the guy who came in was facing it, so he should have stopped her.
This, you're suggesting this guy should have said like, hey, everybody, there's a giant hole in the floor.
Yeah.
All right, let's watch it once more. Okay.
What do you keep on?
Look, I just made a giant hole there. Okay. Hey, let's not tell her there's a hole in the floor. Okay?
Isn't it look so
If you watch it, we'll watch it one more time. It actually looks like this guy starts laughing a little bit. I'll show you. It's not a very clear video, but. Okay, she goes down. Yeah, I'm going down in the basement. Great, la-di-da-di-da.
Who decided, hey, we're gonna put the basement stairs in the middle of the store?
Oh, yeah.
Okay. If-then statements, also known as conditionals. We have a lot of words today that start with C-O-N. I don't know why. If today is Monday, then yesterday was the weekend. Is that a true statement?
Yeah.
We'll come back later and talk about true or false, but just to get us started, is that a true statement?
Yes.
Yeah, okay. That first part, the if statement, is called the hypothesis. The second part, with the then, is called the conclusion. Tommy, give me an if-then statement. Doesn't have to be true or false, just an if-then statement. If
I'm thirsty, then I will get a drink.
Awesome. True statement?
Yes.
So every single time you were thirsty, you went and got a drink. Doesn't matter what you're doing. You could be driving in a car. You would just jump out of the car and go get a drink. Okay. All right, good. Because we're mathematicians, because we're lazy, we come up with abbreviations for everything. So we use what's called logic notation, and that is where we usually use the letter P to represent a hypothesis, and we have Q represent the conclusion. So we get this thing that says P arrow Q, which is read as P implies Q. Because again, I don't want to write out this big, long, scary sentence. I would like to abbreviate it. And so we'll start abbreviating it. The problem is when you abbreviate it, it doesn't follow good English. So you end up sounding silly. But it'll still work for us. Okay. So something like Monday implies yesterday weekend. Horrible English, but still is a nice little shortening of the longer sentence we had before. Not everything is going to be given to you in if-then form. Sometimes it'll be given in the following form. All cows move. Okay. Now, for this logic unit that we're talking about, we're going to make some assumptions. Like, for instance, dogs have 4 legs, yes? Yes, but you could probably go somewhere, or maybe you have one at home, you have a dog that lost its leg in a tragic accident. Are there 3-legged dogs? Yes. But, again, we're assuming that things in general are true. Is it possible that there's a cow out there that laid its neck on an electric fence and fried out its vocal cords, so now it doesn't move, it just goes, yes. But we're going to assume that all cows move. That's not an if-then form, so we need to write it in if-then form. And when you're writing it in if-then form, you have to ask yourself, which comes first? Does the cow come first, or does the mooing come first?
Cow.
Cow or moo? So what would that be in if-then form? Steven?
If a cow is alive, it moves.
Not bad, but your statement enters a whole nother discussion there. Because what if it's not alive? Can it still move?
Probably not.
That would be pretty creepy. Yeah,
If it's a cow, would it move?
good. If it's a cow, then it moves. If something is a cow, then it moves. If an animal is a cow, then it moves. Because again, if you bring alive into it, then that's a whole nother discussion. Okay? If something is a cow, then it moves. Or cow implies moo, which sounds ridiculous, but still gets the job done.
Could you also do if it moves as a cow?
Ooh, excellent question. Can you all? Okay, hold on, let's back up. We're getting way ahead of ourselves, but we'll do it anyways. Is that a true statement? If something is a cow, then it moves.
Well, yes.
Humans can move.
Let me read it again. If something is a cow, then it moves. What are we starting with? We're starting with a cow. Do cows move?
Yes.
So therefore, it's a true statement. Now, if we do it the other way, if something moves, then it's a cow. Is that a true statement? No, because can you move? Mr. Brown can move. Can you? Anybody remember that book? Dr. Seuss? That's a classic. All right, so we'll talk about that in a little bit because there's actually names for that, which, strangely enough, is on the next slide. Converse has nothing to do with the shoes. If we take the P implies Q and we switch the order, we get something that's called the converse, which is just what we were talking about. So if yesterday was the weekend, then today is Monday. We started before with if today is Monday, then yesterday was the weekend. In other words, you switch the hypothesis and the conclusion. If something moves, then it's a cow. And we'll come back and talk about true or false in a couple of minutes here. So we can also do something called an inverse. And before we get into an inverse, I need to talk a little bit about that squiggly mark. That squiggly mark is called a negation. And it's the opposite. It's just like putting not in front of it. If something is not a cow, then it does not move. Bonus question, what's that a picture of?
Bull, Red Bull.
No. No. No.
A drawing.
A fox.
Waterback buffalo.
A
drawing.
Perry the platypus.
You guys are horrible.
What is it?
What do you call a bull with no legs?
Oh, ground beef.
Ground beef.
Oh.
Get it? Ground beef. It has no legs. What do you call a dog with no legs?
Dead. Sad.
You don't, because it won't come when you call it anyways.
Oh.
What do you call a guy who lost his car?
That one bothered you?
Yeah.
Okay, try this one on for size. What do you do with a dog with no legs?
Kill him.
Take it for a drag. That one better? There's a third one. Are you ready?
Yes. I can't wait.
What do you call a dog with no legs and steel testicles?
Iron Man.
Sparky.
Oh.
Okay, now that's a whole joke motif. Can you put all those pieces together and get that? Okay, right? Because if it has, do I have to explain to you? You got it. Just want to make sure. For those of you that didn't get it, it'll probably be like third or fourth period when it'll kick in and you start
I
laughing.
don't think it would. Yeah.
Explain?
Yeah.
Well, the dog has no legs, so you take it for a drag, but if he has steel testicles,
Oh.
Sparky. Contrapositive. So, let's back up. We start with P implies Q. We switch the order, we get the converse. Okay? We start with P implies Q and we negate both of them. Do the opposite. Now, the opposite is not, I shouldn't use the word opposite. We're negating, we're not taking opposites. So we're not changing on to off. We're just saying not on. Okay? Not a cow. Does not move. If we do both of those at the same time, in other words, we negate it and we switch the order, we get the contrapositive. Not Q implies not P. If something does not move, then it is not a cow. So those are the four. Start with a conditional. We can get a converse, an inverse, or a contrapositive. There are no others. How's it? Backslide.
Wait, so the inverse and the contrapositive come out to the same thing?
No. That's not P implies not Q. This is not Q implies not P. Okay. If you live in Mount Prospect, then you live in Illinois. That'll be our conditional. What's the converse? If you live in Illinois, then you live in Mount Prospect. What's the inverse? If you do not live in Mount Prospect, you do not live in Illinois. And lastly, what's the contrapositive? Good. Okay. Now notice we haven't talked about true or false yet. We'll come back to that because there is a third possibility, which we'll get to in a second. True, false, or CBD. CBD stands for cannot be determined. And this makes people uncomfortable because you're used to statements being true or false. But there are instances where you can't determine whether it's true or false. So, for instance, we talked about this. In order for a statement to be true, the hypothesis has to be true. In order for that to be true, you got to have a cow first. If you don't have a cow, you can't see whether or not it moves. That happens to be a true statement, by the way. If something is a cow, then it moves. In order for a statement to be false, you still have to have a true hypothesis. If something swims, then it is a fish. You need something that swims. That's not a fish.
A whale. A person.
A whale. A person.
A dog.
A dog with no legs. Oh no, they would just sink.
Okay, calm down.
Wait, do you have a dog?
Not anymore.
Why is everyone laughing?
Here's the third scenario. What if the hypothesis is false? Because we need the hypothesis to be true in order to have this true or falseness, if the hypothesis is false, we can't determine it. Okay. If the moon is made of cheese, then Mr. Reedy eats glass. Do I eat glass?
Yes, maybe.
Maybe is the correct answer. Okay. I might not.
Do you need to talk to someone? Or you-
No, I'm good. I'm good because the moon's not made of cheese.
How do you know? How do you know? Have you been to them?
No, but I have some reliable sources.
Like who?
What did you?
The man in the moon.
Yeah.
Man in the moon.
You dead?
Never heard that before.
Never heard that before.
I
Man in
thought
the moon.
it was the man on the moon.
No, man in the moon.
I thought-
Man on the moon is Neil Armstrong.
No, I thought it was Bunny on the moon.
I'm sorry, Bunny on the moon?
Yeah, I feel like there was like the bunny thing on the moon.
Like, who's the man
I've seen that.
in the right?
No, yeah, look at
Okay, what?
Yeah, I thought it was
This is
man.
not.
And
Man
who is
No,
man?
is it like a place?
If man is
Trust me.
All right, so What you should have noticed is that some of these will not be easy to determine whether they're true or false. So I have a couple theorems that will make your life a lot easier. In other words, determining if the original conditional is true or false is not that difficult. If something moves, then it's a cow. That's pretty easy to determine true or false. But when you start throwing in those nots and switching the order, it gets a little confusing. So therefore, these two theorems will help. There you go. There's a connection between the contrapositive and the conditional. So if the conditional is true, well, not even that. Whatever state the conditional is in, whether it's true or false, the contrapositive has to be the same. Whatever state the converse is in, the inverse has to be the same. So they're always linked. Converse and inverse together, conditional and contrapositive together. Therefore, when we get into these complicated statements, you don't have to bother figuring out if it's true or false if you could just figure out the true or falseness of the conditional or the converse. Okay, conditional and contrapositive go together, converse and inverse go together. All right, let's get to an example here. I know I'm going fast, but we got to get this done. If an animal is a bat, then it can fly. True or false?
Oh.
Bats fly.
True.
That's a true statement. Okay? What's the converse of that statement? If an animal can fly, then it's a bat. Is that true or false? False. Counterexample. Bird. Condor.
Falcon.
What's that? Eagle. Falcon. Superman. Well, technically it's an animal, yeah. What's the inverse? If it's not, no.
If a bat is not an animal.
Say again?
If a bat is not an animal, then it cannot fly.
If an animal is not a
Oh,
bat.
yeah.
If an animal is not a bat, then it cannot fly. That one's a little tricky to figure out, so don't bother. Just look at what we had for the converse. We said the converse was false, so therefore the inverse has to be false. And then lastly, what's the contrapositive? Good. If an animal cannot fly, then it is not a bat. True or false? True, because the original conditional is true. So don't rack your brains trying to figure that out. Just make sure that these two are linked and these two are linked. Whoops. Okay. These two are linked and those two are linked. Let's go back to one of our examples here. Where was it? This one. Is the original statement true? Yes. And the converse was what? If you live in Illinois, then you live in Mount Prospect. True or false? False. Counterexample? You live in Springfield. What's the question, Augie?
Wouldn't the first one be false if there's a Mount Prospect somewhere else?
Yeah, there is a Mount Prospect somewhere.
Yes, but again, it's like the cow that put its throat on the electrical fence. What was the inverse? What's the inverse? If you do not live in Mount Prospect, then you do not live in Illinois. True or false? False. Because the converse is false. I don't care about the knots and all that other gunk. Contrapositive. If you don't live in Illinois, then you don't live in Mount Prospect. That would be true or false? True, because the original statement is true. Okay, good. I think we're good. That. Baby bat is called the pump. Yeah, good stuff. Okay. One last thing that I want to talk about, and that is statements. Wait, don't start packing up. Listen first. You might want to, in fact, write this down. Statements that work both ways, meaning the conditional and the converse are true, are what's called reversible statements. When we write definitions in the future, we want all our definitions to be reversible statements. And one of the things that you're going to have to do on the homework tonight is write a reversible statement. So, for instance, we had the cow one. If something is a cow, then it moves. That is not a reversible statement because the converse says that if something moves and it's a cow, then we prove it to be false. But again, if the conditional and the converse are the same, both true, then it becomes a reversible statement. Okay. Good? Beautiful.
Is the homework up?
No, it's not up yet.